Water, the essence of life, a fundamental need for human existence. Our planet, the blue planet, is covered largely with water. The oceans blanket 75% of its surface. In spite of this abundance, we are faced with a growing water problem. Of the Earth's water, 97% is salt water from the oceans. Only 2.5% of the Earth's water is fresh water, and of that amount, approximately 69% is frozen in glaciers and ice caps. That leaves just 0.75% of the world's water in fresh groundwater. Where does this water go? Traditionally, most of the water we use in our homes comes from groundwater sources, such as wells, or from surface water like rivers, lakes, and reservoirs. On average, humans use 100 to 200 liters of water a day for domestic use. And although a lot of water is consumed by industry, the largest use of water is for producing the products we eat and wear. Consider these facts. It takes 245 liters to produce 0.25 kilograms of wheat. It takes 2,700 liters of water to produce an average-size cotton t-shirt. 1,230 liters are required to produce 0.25 kilograms of cheese. And 13,000 liters of water are needed to produce 1 kilogram of beef. The world's population is expected to grow every year, as much as 40 to 50% over the next 50 years. And with it, the demand for water will also rise. But there are issues with our existing water sources, from pollution to climate changes, that are literally drying up our resources, and leaks both in our homes and in our aging infrastructure. How then can we solve this critical problem and provide adequate water to a world thirsting for a solution?
Water conservation is really a very crucial part of the overall water strategy. Every drop of water that you save is another drop in supply.
We very much encourage water utilities to strengthen their conservation efforts before they turn to desalination. But in many communities, they still need additional water supply even after they have fully considered the conservation measures. There are in fact communities around the world that rely 100% on desalinated water for their supply.
Desalination is the process of removing salt from water, also called desalting or desalinization. There are two major processes used to desalinate water: membrane processes and thermal processes. In thermal processes, water is essentially heated to the boiling point. The water vapor rises and condenses into pure water, while impurities are left behind. Membrane processes represent the fastest growing desalination technology. First, the water passes through a sophisticated intake system. In the membrane process, water is pre-treated. And then, under high pressure, it passes through a reverse osmosis membrane. The final stage is post-treatment. Over the past several years, the desalination industry has focused on development of technologies that have successfully reduced power consumption and minimized the impact of rising power costs on plant operations. Environmental responsibility is also a top priority. Through technological advances, the industry has developed sophisticated intake designs that protect marine life, as well as improve outfall designs and monitoring techniques. Today's desalination plants are huge and vital pieces of infrastructure. There are nearly 15,000 desalination plants in the world, the largest of which produces more than 900,000 cubic meters of water per day. And planned facilities are even larger, at 1 million cubic meters per day of capacity. The International Desalination Association, or IDA, is the global hub for the desalination industry. As traditional resources come under increasing pressure, Desalination has the power to provide a new and reliable source of fresh water to a thirsty planet. IDA invites you to learn more and discover desalination for a better world.
It's time to set the record straight about some myths and misconceptions about desalination. First, some perspective. It is clear that the world's water resources are under tremendous pressure. The Earth is covered largely with water. The oceans blanket 75% of its surface. In spite of this abundance, we are faced with a growing water problem. Of the Earth's water, 97% is salt water from the oceans. Only 2.5% of the Earth's water is fresh water, and of that amount, approximately 69% is frozen in glaciers and ice caps. That leaves just 0.75% of the world's water in fresh groundwater. And yet, over the next 50 years, the world's population is expected to grow as much as 50%.
This will put a crushing demand on water supplies that are increasingly becoming polluted, drying up, or lost through leaky, aging infrastructure.
Desalination provides new and reliable sources of fresh water to our thirsty planet. Already today, an estimated 300 million people in 150 countries rely on desalinated water.
The desalination industry provides water-stressed communities with a viable option when water conservation is not enough. And we're taking aggressive steps to cut costs, reduce energy consumption, and be environmentally responsible.
In reality, it is expensive to treat water and to get it to where it's needed, regardless of how it's produced. Sometimes, however, the real cost is not apparent to consumers because producing the water may be heavily subsidized by local providers. In fact, the cost of producing water using traditional treatment methods is actually rising. In contrast, the cost of desalinating water has come down over the last 20 years. Today, the average cost of desalting water ranges from 75 cents to $1.25 per cubic meter. Desalinating brackish water costs even less. This downward trend is expected to continue, and the gap is narrowing between desalting water and producing it by traditional means. Depending on location, desalination may be even less expensive.
In parts of the world, it's less expensive to desalinate seawater than it is to deliver fresh water from either groundwater or surface water sources. In parts of Southern California, it takes more energy to pump water from Northern California than it would take to make drinking water from the sea.
What's more, desalination plants can share the same water distribution network already being used in traditional water facilities.
A desalination plant can be an important component of a community's infrastructure and of its overall water portfolio.
Thanks to technology improvements over the last 20 years, the energy required to produce desalinated water has been reduced by as much as 50%. Technologies include more energy-efficient membrane processes like reverse osmosis, and energy recovery devices which capture and recycle more than 50% of the energy used.
The advances that the industry is making in terms of energy savings are really impressive. Every year, new breakthroughs are announced, and new companies are founded to develop those breakthroughs and bring them to market.
Thermal desalination, which primarily uses steam, is also becoming more energy efficient. Advances come from growing use of multiple effect distillation and the building or retrofitting of plants with hybrid systems that incorporate both membrane and thermal processes.
Many desalination plants are now co-located with power plants. This allows the desalination plant to use some of the exhausted energy from the power plant to produce water at a lower cost.
Renewable energy technologies are increasing and could even eliminate the use of fossil fuels. For example, the majority of desalination plants in Australia are powered by wind energy. And Saudi Arabia, the world's largest producer of desalinated water, is developing a solar-powered program.
With advances in renewable energy, desalination has become more planet-friendly than ever before.
When designing desalination plants, protecting marine life has become a priority.
The industry is aware of our responsibility to practice desalination in a way that safeguards our marine flora and fauna. We're committed to protecting even the most sensitive species, and we've developed many technological breakthroughs to help us achieve this goal.
Engineers have redesigned intake pipes so that when feed water is brought into the plant, the chance of harming fish and fish eggs is greatly reduced. Many options are available, including offshore intakes, sub-seabed intakes, and passive intakes. And engineers have devised and sited various plants' outfalls so that discharges do not harm aquatic life.
It's important to disperse discharges from desalination plants, and there are many means to do so. And they include multi-port diffusers, blending with cooling tower water, and new techniques such as forward osmosis. We're even developing ways to extract valuable salts and minerals from the concentrate stream.
Meanwhile, ongoing monitoring programs are constantly being enhanced to closely observe and protect aquatic life. 4 years after construction of the Kwinana plant in Australia, marine life flourishes around the outfall area. What's more, monitoring data here and elsewhere aids the design of other plants.
Monitoring programs are another important step in environmental responsibility. Combined with specially engineered intakes and outfalls, the desalination industry is ensuring that marine life near desalination plants continues to thrive.
Water is a precious resource, and conservation, both by individuals and communities, should be the first step in water management. However, even after all homes are equipped with water-saving fixtures and all leaking pipes are fixed, conservation measures alone are not enough to provide enough reliable water to meet increasing needs. Expanding populations and economic growth, pollution, drought and climate change all require alternative solutions.
In some parts of the world, people are desperate for new sources of water. Without desalination, they'd go thirsty and economies would suffer. Desalination gives people access to previously untapped and new water resources.
For most cities and towns around the world, desalination is just one part of an overall water portfolio.
It is not a question of conservation or desalination. For example, Singapore, which has perhaps the world's most aggressive conservation program that includes collecting rainwater and water recycling, also includes desalination in its water management toolbox.
Desalination is rapidly becoming a more economical, energy efficient, and environmentally friendly clean water solution.
Desalination is like a well that won't run dry. It gives the world's growing population access to a reliable and sustainable source of fresh water.
Desalination is a critical component for water solutions in the 21st century. It's important to dispel the myths and misconceptions surrounding its use, and focus instead on desalination's ability to create a better world.